Hello, this is Tyler Erb, and we're going to talk mass points part 2. In the previous video, we did an intro to mass points, how to use it, why it works, and some more simple problems. Again, the big thing we want to look out for is cevians and anytime we see a ratio. So in this figure, DE are points on BC on triangle ABC, such that B to D to D to E to EC is a 1 to 2 to 3 ratio. So instantly that's a red flag for mass points. The other piece we know is that BF is a median, even though it kind of doesn't look like it in this picture. We know BF is a median, so we're going to have that 1 to 1 ratio on AC. We're also told that we're essentially splitting this into X, Y, and Z. And so we're going to use mass points here, but we have a couple issues. Issue 1, if we look at our ratio, how are we supposed to make kind of a teeter-totter or a scale with segment BC? There's no way to do it. Think about it, if you were to do a teeter-totter and it had 2 points as the fulcrum, that wouldn't work. It'd be the world's worst teeter-totter. Same thing kind of if we're trying to balance this as a scale. So the other issue we have is, how are we going to use those 3 values and that 1 to 1? So what we're going to have to do is split this into 2 separate triangles. We're essentially going to take one cevian at a time from point A and use that to try to find ratios along segment BF. So let's first start by using this with AD. So if we look B to D and D to C, we essentially would realize here, well, if we have this as a 1 and a 2 and a 3, this will become a 1 to 5 ratio, right? Because we can add that 2 parts for DE and 2 parts for EC. Next, if we're looking at BF, and this intersection point here is G, we realize this is a 1 to 1 ratio. So now we're going to start signing masses. C is the shared point, so we have to look at AF and BD. They both would assign a mass of 1 for C, so we don't have to worry about multiplying or dealing with any ratio. This lets us then assign a mass of 5 at B, thanks to DC. And then we can assign a mass of 1 at A, thanks to FC. This would leave us as a mass of 2 for F, right? Because F is the combined mass of both points A and C. And D would have a mass of 6, thanks to the combined mass of B and C. Again, we now can figure out this mass at the center point G, looking at segment AD, right? 6 plus 1 would give us a mass at 7. And we can double check that we did that correct with BF. BF has that mass of 5 at B and 2 at F, so that also adds up to 7, which means we know we're doing something correct. From here, we realize that the ratio for BD to DF, or sorry, BG to GF would be a 2 to 5 ratio. But the problem is we want to compare BG to GH and HF, right? We want to compare it to everything. So instead, what we can do is compare this as BG to BF, essentially the part to the whole. So if it's a 2 to 5 ratio with BG to GF, that would be a 2 to 7 ratio for the whole length. So now what we're going to do is we're going to essentially take this and now attack it one more time. But this time we're going to use segment AE. Right? We want to use that other cevian because that's the only other one that we can deal with. So this intersection point here would be H. And again, we have that 1 to 1 ratio because FB is a median. And now we have a 3 to 3 ratio here, which we can actually simplify that down to make it a 1 to 1 ratio if we want. Again, we try to look at what we're dealing with in terms of the mass at C, because that's that shared point. We can use 1 here, which is really nice, because then we can just assign 1 for B and 1 for A, which means E would have a mass of 2 and F would have a mass of 2. This then gives H a mass of 3, and we see that that works for both AF and or sorry, AE and BF. So now looking at BF, we realize that HF would have a ratio of 1 to 2, right? And some of you may also realize that we're kind of dealing with H being a centroid as well, right, in this diagram. So if we know that HF to BH would be a 1 to 2 ratio, then that means that HF to all of BF would be a 1 to 3 ratio. So at this point, we realize, well, we're not going to actually be able to figure out what GH is, right? But we do know the two other fractions. So we can figure out that GH over the entire BF would have to essentially be what we're left with, right? Because we know the entire length of BF in this scenario should equal 1. Now, we're told that X, Y, and Z all have to be integers. And so what we can instead kind of deal with here is realizing that this should be, we need a common denominator, so we can make this 6 out of 21, and this is 7 out of 21. So if we want to find GH, we realize that GH would be 8 out of 21. But in fact, we don't really care about that. The only thing we need to know is that the sum of X, Y, and Z. And so in this case, it's going to be 6 plus 7 plus 8, which will add up to 21, which we realize is also our common denominator, right? So we didn't actually have to find GH. We could have just found our common denominator of 21. All right, let's try the next problem. The next problem deals with something called splitting the mass. Let's look at this problem first. Point D split segment AC into AD to DC is a 3 to 2 ratio. BE to EC is a 3 to 5 ratio. And we're told F is a midpoint, which kind of means CF is a median again, but we can also just think about this as a 1 to 1 ratio. So we instantly have an issue here, and it's the fact that DE is not a cevian, right? So we're dealing with ratios being created by points that aren't cevians, which means normal mass points isn't going to work for us, right? We can still make mass points work, but we're going to have to do something called splitting the mass, which means we're still going to find the mass at C, but we're not going to be able to have a common mass for it. Let's see what we're looking at. Let's first start by looking at A and B. Notice normally we would say, oh, look, C is a mass at 3, right? And then you'd go, well, that means B needs to be 5 and A needs to be 2. But then you run into an issue automatically at AB, right? AF to BF needs to be that 1 to 1 ratio. And we know that 5 is not equal to 2. So we know we kind of have a problem here. Instead of going to C, which is what we normally do because it's the cevian, we're first going to balance out that side that's opposite of C. So we're going to say, okay, well, this needs to be a 1 to 1 ratio. And currently I have a mass of 5 and I have a mass of 2. So this kind of gives us a problem. Instead, if we scale this up to a 10 to 10 ratio, this works out for us because now we see that 10 is divisible by 2 and 10 is divisible by 5. So we're really just scaling up our ratios for AC and BC. So what this is going to mean for us is that on AC, we multiplied by 5. So this would give us a mass of C on the side AC of 15. On side BC, we scaled up by 2. That means C should have a mass of 6. And I know you're thinking, oh no, we still have the same problem. C doesn't have the same mass. And I totally understand where you're coming from. But what we can do is called splitting the mass, which means we're going to assign C to be the sum of these masses. And this only works because we're not dealing with DE as a cevian, right? It's just a segment connecting these 2 points on the sides. And we'll see that this actually balances out. So let's call C a mass of 21, which would also tell us that it needs to balance out with point G. So let's look at F. F has a mass of 20, thanks to A and B. And we know G should then have a mass of 41. Well, let's look at points D and E. D has a mass of 25, thanks to A and its side of C. And E has a mass of 16, thanks to 10 and its side of its side of BC. So from here, we realize that 25 and 16 do add up to 41, and 20 and 21 add up to 41. So our triangle is still balanced, right? And so this, when we're dealing with splitting the mass, this specifically works when we are balancing the other side first, and then we work into that cevian point, that C where they share the mass. So now our final question is to talk about DG to GE, which would be 16 to 25. Again, the 16 from here, the 25 from here. So this gives us a final answer of a ratio of 16 to 25. All right, well, I hope these two videos on mass points were helpful. Again, if you have any questions, please leave them in the comments and I will answer them as soon as possible. Have a great day.